First of all, thank you for coming to this session. Hopefully, you'll find it useful and you'll learn something today. My name is Maddali. I'm a senior solutions architect at Red Hat. I've been with Red Hat from actually more than 3 years now. Been working with Southeast large customers, kind of helping them on the solutions. It involves obviously our JBoss middleware portfolio, along with the containers and other stuff. Right. So what we're going to discuss today is I just briefly put 3 buckets in there. So anything, usually when I start with any technology, I just want to know why, what, and how. Right. The why part is why should I even care about Wildfly, right? And the second part is what is the benefits and why should you look at all the benefits that it brings on the table. And in the how part, I have a bunch of demos. That starts with hello world, as well as differentiating some fat jars, thin jars, etc. Along with general configurations that you usually have to do for especially for database or any kinds of properties stuff, right? And we also talk about some of the cloud native stuff, things like circuit breaker, health checks. The way demos are laid out is the first part will be mostly based on the fat jars, and the second part will be we'll be working on the Kubernetes OpenShift part of it. All right, the first part is, so why Wildfly Swarm, right? So there is no talk obviously without talking about microservices, right? So how many of you already using microservices here? Right, cool. All right. Have anybody heard about Wildfly Swarm before? Okay. All right. So what are so we just come from the background of all this, as in what we are trying to solve with the Wildfly Swarm, right? The first part is the microservices, right? So for me, obviously, the definition for each one is different. For me, it's an architectural style. Essentially, it's somewhat similar to SOA, but it's kind of different a little bit, especially when you're talking about containers and cloud native stuff, right? And the primary reason, at least everybody is looking at, is because it provides a way to deliver your software much quicker, right? So that you can independently deploy your services without having to touch many of the other systems that are not necessary to touch, right? And also, it's essentially a way of defining fine-grained services which are loosely coupled. They can independently scale. As well as if there is an error or an exception somewhere, you do not want to bring down entire system, right? So that's a whole, at least the purpose of the microservices, right? So the first part is the technology in terms of how you implement it. The second part is about the process and the people, right? Essentially, it's a 2-pizza rule. I'm sure most of you guys heard about it already, which we tend to forget about the process and people part, right? For a successful implementation of microservices, obviously, having a team, a small team who are focused on doing just one business function or set of business functions is essential for microservice, success, right? So rather than you checking in the code earlier, at least I used to check in my code at 4:30 p.m. in the night and just go and sleep, right? Versus where the infrastructure team used to just break their head just deploying the code in terms of figuring out what changes went in and things like that, right? So in the monolithic world, obviously we have a bunch of services running on the left side than the first box, right? So obviously it might have made up with your SOAP services, RESTful services, EJBs, or whatever system that technologies or subsystems that you need. Versus in a microservices world, you may not be deploying all the subsystems or all the technologies or APIs of EE together, right? You may be just using a RESTful API, and you do not have to deploy EJBs in the RESTful container, which you are not even using it, right? So essentially, if you're not using it, obviously the unused subsystem is still there, right? As in things like the Wildfly Swarm, Wildfly itself takes a different approach in terms of how to start the services and all that. But you still want to tune it further in a way that you just want what what you need. Essentially the term is right sizing your runtime, right? So before we get into a little bit of Swarm piece, right? So how many of you know about Wildfly or are already working on Wildfly as an application server? Right. Okay. All right. So it goes to the history as in initially, the actual architecture is based on the first part is a JMX microkernel, right? Essentially everything used to be mbeans, right? Everything used to talk to mbeans. And after that, in the 5.6 world of JBoss, it kind of obviously needed a way to inject POJO services, right? Obviously, that's not possible with, or at least there's no better way to using mbeans. So we had to refactor, at least JBoss guys have to refactor into a JBoss microcontainer world, which gives them CDI part, things like, not CDI, as in at least to be able to instantiate POJOs and stuff like that. And the last one, which is the latest release, which is 11, I guess now, it's based on JBoss modules, or it's based on module service container. So what it means is the system, the entire EAP or Wildfly system is made of a bunch of modules, right? And there is a module, essentially there is a module microservice container behind it, which is actually starting all the services that you need behind the scenes. Earlier with the servers, obviously, we never used to have, we never used to use all the CPU cores within the system, right? Now with the modular service container, the system itself is spanning multiple threads, so that when you're starting the server, you're actually parallelly starting all the services at once, whatever services you configured. When I say services, I'm talking about subsystems, right? So that's why you see the boot time. If you look at the Wildfly, the boot time is like less than 2 seconds. And essentially the core of Wildfly is 26 meg, which is just the core. And if you look at the full profile of the Wildfly, is around 120 megs. It's pretty slick. The start times are even it's actually less than, as I said, 2 seconds, right? And that's kind of the diagram which says, which is highlighted where depending on what services. If you see on the right, you have 331 of 577 services started. What that means is it's only starting what are the services that are required, and then putting the rest of it, which are not used, as a kind of lazy loading, right? That's why that's one of the reasons we are able to kind of achieve the fast boot up times, along with the less memory footprint. So, like I said in the previous slide, right? So the EAP or a Wildfly system is based on a bunch of subsystems. So a JPA is a subsystem, JAX WS is a subsystem, security is a subsystem. Sorry about that. Subsystem. So all these subsystems are made together to make it as a server runtime, right? So you can pick and choose. Even today in the Wildfly server, you can pick and choose which modules or subsystems that you want to start, right? So it's essentially made of a bunch of runtimes, which are very good in doing what they are doing, right? And even the memory footprints of these subsystems is actually very, very less and very thin. So that's a part of the microservices and a little bit on the Wildfly. So the second part of to the what part of why part of the Wildfly swarm is the EE, right? How many of you using EE today? Java EE. All right. All right. So for Java EE, so if you ask what is Java EE, it's essentially a bunch of APIs, right? Giving you a bunch of APIs so that your code is portable. If you're writing to some API, Java API, at least your code is portable. But if you look at the release cadence, right, for Java EE, it's actually essentially 1 to 2, it's 5 years, and everything is actually, for every major release, is actually 5 years, right? But how do we get things like from 2010, at least, we have so much innovation happened, right? Things like containers, microservices, and all the cloud native stuff. So there's nothing wrong in this release cadence. It's because it's a way of standardizing effort, right? Usually, most of the APIs come in the JEE world, Java EE world, when they're already adapted by most of the customers or users, right? But if you want more of a cloud native capabilities, right? Things like fault tolerance, health checks, distributed tracing or service discovery, etc., which are not essentially part of Java EE API at all, right? So obviously, you have to grab some other frameworks to kind of achieve that kind of functionality, or look at a container platform like, if you're doing containers, container platform like Kubernetes or OpenShift, at least to provide some sort of this functionality, right? So that's the background, right? So what we're trying to solve is essentially giving a pathway for Java EE developers to develop microservices, right? Versus which we didn't even have it before. So the Drop Wizard initially started with this FatJar approach. They started with just the JAX supporting just the JAX APIs, right? And later, obviously, Spring just took it over, and they implemented this own stuff, which is called Spring Boot, which is, and the third part, which is what we are working on, is the Wildfly Swarm, essentially providing the pathway for JEE developers on the APIs. Right? On the container, the servlet container it uses is the Undertow, which is actually based on NIO. It's very fast. It uses, so you can do all the asynchronous sort of mechanisms in there. Things like, if you want to do a gateway aggregation and things like that, it's a great place to use it. And actually, most of the folks I talk to, they use Undertow plus Spring Boot as a kind of flavor in some way, right? If you are doing some Spring APIs, right? So what Wildfly Swarm is actually extends. It's using the same capabilities of Wildfly application server, and extends the capabilities for you to be able to, one, do a FatJar approach, develop microservices, as well as provide some, fundamentally a common APIs to do cloud native stuff, right? So if one liner is Java EE plus micro profile is essentially equal to the Wildfly Swarm. Of course, there are more to it, but the foundation of it is what it is. So before we get into the next step, I just want to show a quick demo so that we'll revisit again the same demo and then see if it kind of makes sense, right? So I'm just going to create a brand new project here. So I'm using JBoss Forge, which is just an scaffolding tool on top of JBoss Developer Studio. Here I'm just going to create a new project, right? And it is asking me what's a project. I'm just saying AJUG first demo, and then it asks you to pick a stack. I'm just picking a Java E7, and I'm just say create. Right now, my project is created here. Right. Let me close the rest of the systems here. Is it visible, or should I make it a little bigger? I think that's it. All right, so this is, again, I haven't done anything in terms of swarmifying it. It's just essentially a way to create a EE using the tools, things like Forge, right? So now what I'm going to do is I'm going to pick a stack, as in I just created a dummy EE app. Now I want to pick a stack, as in I want to just create a RESTful app, right? Let's say I want to create a new endpoint here. Right, an endpoint, and it asks you a bunch of stuff here. I'm just picking whatever it is, and then I'm just giving a name. In this case, I'm just saying hello endpoint. Right, that's it. And I'm just saying method, just create one get method for me, and I'm just saying finish. Right. So if you look at this project, now it created a hello endpoint here. It just does, just says method in do get invoked. Right. And this is the other one, which is the context path one, right? So now this is a simple EE app. Now how do I swarmify it, right? So now let's call our friend Forge, and then say, hey, can you swarmify my application, right? So that's it. Now my application is swarmified. So We'll get into the details in terms of what it's doing behind the scenes, but I just want to give you a feel of how it takes to create an application, a Swarm application. Now your application is created, right? Sorry. I'm going to run the application. Just going to create a new Maven. AJUG first demo, run, speaking my path. And the way you run, there are different ways you can run Wildfly Swarm application. In this case, I'm just doing Wildfly Swarm run, right? So fly, run. Hopefully this will work, but so what it's doing is it's taking that sample endpoint, simple endpoint, and creating, taking the subsystems that it needed for running that small endpoint, creating that server runtime along with your application, and then it's creating a fat jar for you, which has your application, your server bits, everything that is needed to run, right? So let's go and invoke. Oh, you know what? It's actually REST, I think. Yeah. Yep. So that's it. I just take existing app. You can just think of just taking your existing EE app and just swarmifying it, deploying it, and showing it. Right. This is just one way, and there are actually different ways and different tools to create it. But I just want to start with this, right? So now let's go back to the presentation, and then we'll come back. Go ahead, sir.
What was the error that showed up there?
It's actually a warning.
Oh, just a warning.
Yeah, it's just a warning. It's not error. All right. So let's before we come back there, right? I want to show you the directory structure in terms of what it's created. Let's go back. CD workspace, right? CD. What was that? Demo. Yeah, AJUG, right? Then go to target and list it. Right now, it created a swarm for the fat jar is -swarm. And the second one is the war file. It also creates a war file for you because I put the Maven plugin as a war file. So it's taking that war bits, putting the subsystems together, deploying it, running it. You can run it with if you want to run it as a Java jar, you can still run it. So rather than saying Wildfly run, you would say Maven package and then run Java jar. Right. Let's go back to our presentation now. Right. So like I said, how many of you heard of microprofile before? Cool. All of it. Okay. So microprofile is again standardizing APIs for microservices, right? Java microservices essentially. So it provides obviously, like I said, one of the issue is the release cadence with the EE, right? Again, it's nothing wrong with the release cadence. It's just the standardizing process in the EE specs. Versus the microprofile gives you much more. The intent of the microprofile is to standardize or give common APIs that you can use it. Give the APIs quicker so that it provides a path for Java EE developers for doing the microservices, right? Essentially, we have been collaborating. Obviously, Red Hat is one of the vendor in collaborating with other community members, right? Individuals as well, to come up with the specs around the microprofile. So up to now, I think 1.3 is released. 1.2 essentially Wildfly Swarm right now is 1.2's implementation of microprofile. And there are things like 1.3 and 2.0 has a bigger goal, as in putting a lot of APIs in terms of standardizing that microservices, right? In the 1.2 profile, this is what we have today in the 1. Which is Wildfly Swarm implementation. CDI, specs, config, fault tolerance, health checks, which we obviously we will not be going through everything, but we'll be going through the health checks. We'll be looking at the fault tolerance piece here, as well as getting you up to speed on how to develop Wildfly Swarm applications. Right. So these are just the APIs, right? Obviously, implementations is Wildfly Swarm has its own obviously standardized implementation behind the scenes, which we'll look at it. So now getting into the concepts of how when I show you the demo, how it was built, right? So if you look at all I did there was just creating a RESTful API, right? So you can think of RESTful API as a fraction in a Wildfly Swarm world. So what is a fraction? A fraction is a API that provides a set of capabilities, right? In this case, it's a RESTful is an API which is equal to fraction. So essentially, whatever APIs that you want, you will include those fractions in your pom.xml, and these fractions are downloaded or retrieved based on the Maven coordinates, right? Whatever coordinates you put in the Maven, those are retrieved by Maven coordinates. And then once the fractions are all bundled, it makes up the capabilities you need for the server or the application server to run your application, right? So fractions is one of the main fundamentals behind the Wildfly Swarm. And as I said, the way it works is, once you have the pom.xml, the fractions are here. Your plugin is pulling all the fractions through the Maven plugin, the Maven artifacts, and then it's making your self-contained executable here, along with your classes applications here. Right? Any questions? Please feel free to stop me if you have any questions. Sorry if I did. Yes, sir. Yes, there is a plugin for Gradle too, but primarily what I know is that all my customers are using Maven, so I'm focused on Maven more than Gradle. But there is a plugin for Gradle as well in the community. So here in the same example that we kind of saw before, where if you have to make up your application, which just RESTful service on the right, what we did is essentially just put a dependency on the fraction, which I'll show you how it works, as in how it made up in the next demo. But essentially, the fraction is just all it included is JAX-RS fraction, and eliminated rest of the subsystems which you don't even need for your application to run, right? So coming to the tooling question, obviously you had asked already. The tooling, we have different ways to create that, get you started, as well as to kind of work with Wildfly Swarm. First one, Maven Gradle, the Forge add-on which I showed you just in the demo. That's the second one, where it helps you to create obviously scaffolds your code, things like you could create an endpoint entities, or swarmifying your application. It also you can do Fabricate. If you have heard about Fabricate, it also helps you to set up the Fabricate projects, as in plugins to deploy into the Kubernetes OpenShift world. And it also has a bunch of extensions for Eclipse, JBDS, which you always show, IntelliJ, as well as a project generator, which is similar to your Spring IO initializer, right? So basically, as in the Wildfly Swarm IO generator, which is what we'll use for our next demo, where we create the application from there, and just show you how kind of easy to. So the URL is Wildfly. So Wildfly Swarm, wildfly-swarm.io/generator, right? So here, you can create or pick and choose the capabilities that you want for your system. Let's say in this case, I'll put the AJUG demo 2, right? Now I'm picking the capabilities. These capabilities are again the fractions, right? Now let me pick REST, right? So REST again is divided into a bunch of fractions. Let me just pick JAX-RS, right? So I'm just using JAX-RS. here, and now I'm just generating the project. So what it does is, obviously it downloads the zip for you, and then so where is right, so let me import the project, existing Maven project, space. Oh, it should be in document. Yeah, AJUG demo. Thank you. All right, just say finish. All right, what it did is, obviously created a project structure along with the swarm, swarmifying it, the application, created a hello endpoint, right? And then let's look at the endpoint. Obviously, it's just returning hello from Wildfly swarm, right? So let's look at the POM. This is the important piece. Is how so the way you swarmify your existing or your new app is similar. So what you do is you include the Maven plugin, swarm plugin, right? And then in this case, because I said just use the JAX-RS, it included the fraction, which is essentially identified the coordinates, right? So JAX-RS is the only dependency or the fraction dependency I have in this case, right? So that's it. That's how you just create a Wildfly swarm app. So all you need is a plugin to run, and then your fractions that you want for your application. In this case, just I have a RESTful service, right? So JAX-RS. Now let's go back to try to run this. Demo 2, run. How do we run it? Wildfly swarm, run, right? Any questions before it's actually building? Yes, sir.
So your dependency in there was on something for Wildfire. When is the resolution to go and actually get the JAX-RS jars?
So the first one, which one we were talking? Is that here?
Right there in your dependency, you just mentioned that the group ID is Wildfly Swarm.
Correct.
Where does it actually go and fetch the real JAX-RS jars?
It's fetching from the repo, Maven repos.
At runtime or when you're deploying?
No, not in the runtime. When you're deploying, so it's in the runtime. You need the subsystems in the runtime, right? The coding part, as in the APIs for you to create the compile time, are all included in your Wildfly swarm, as in the EE bomb here already. So we're good there at the compilation time, but for a runtime, you just need the JAX-RS piece, and then it made up of that particular fraction, and then it runs. All right, so /hello, it runs now, right? So, yes, sir.
This second example is very similar to the first one.
Right.
So why this one, how like the path is kind of work in the previous example, you have to adding a REST. What's the trick?
No, there is no trick here. Earlier, I have in REST the context path starts with REST there. Let me show you that. So, and then here I don't have any. I just put the context slash. That's it. Then you're just doing /hello. Most of the times you do this way because anyway one service or one set of functionality is deployed in a microservice. Right? It'll be slash and your service.
So the first example, second example is very similar, and we're using a little bit different technique to create this boilerplate.
No, in the first one, it actually asked me to pick my context path. There I put REST, which is defaultly populated /rest. If I just put there /, it would have created the same thing. You can pick and choose when you're creating in either ways. Right. So we looked at the POM file. Now let's go back to the presentation. Actually, so now we did now our application is deployed, right? So what we can do is, so this is a demo, right? So now let's say you want to expose an API for a REST API description, right? So how do we do it? Like using Swagger, right? So here I'm going to create a documentation part, right? Exposing my documentation. This gives you a list of fractions that are available. I believe there are around close to 200 fractions today. So you can pick and choose which one you want. Right now I'm going to pick the Swagger because I want to expose the documentation piece. So I'm just picking Swagger here, right? Right. Now, so what it did is when I said add fractions, add a Swagger fraction, all it did is it just added a dependency on my in my pom.xml. Once you're familiar with the system, you can just probably copy paste it, right? But it gives you at least a good starting point, until you get the familiarity with the system. So now I added the Swagger piece, right? Obviously, I have to add little endpoints, as in the description. There's an API one. I'm not going to type. I'll just take it from I should have remembered the names rather than just going through this. So I'm just going to just put my the annotations describing what my API is. Right. And this part is the same regardless you're doing in a Java EE versus just doing as a microservice, right? So I added my documentation now. This is second demo, right? Right. All right. So now again, all we have to do is run it. Remember, I added a new fraction, which is Swagger here, right? So once that is up and running, yep, right. So it got deployed now. Now, if I want to see the documentation, all I do is swagger.json. Whatever documentation I put here, everything is visible. So if you want to look at just what the documentation is for that single API, it's visible. So it's pretty simple exposing it. Right. Any questions before we go back to slides again? Sir, what was the question? Sorry, I couldn't hear.
Support for the Spring Boot with the nice UI to Swagger? Do you have that?
Support for
Swagger HTML.
Yeah, you have the Swagger UI. Yes, we do have Swagger UI too. So you just have to add the fraction of the Swagger UI, and then once you add that, you should be able to see the UI as well. All right. So just to recap again on this one, right? So the way we enable Swamified an application, regardless if it's existing or new, is just put the Maven plugin, right? And then in the first case, we added just the JAX-RS fraction, and then build and run it, right? Again, there are different ways to build and run it. The first one we used is Wildfly Swarm run. You can also do Maven package and then do a Java jar specifically on that Swarm, right? Or you can run it from your IDE as well, which the demo we just did it, right? Right. So other thing, obviously, this is a lot of discussions in the different groups about is that ideal to have a fat jar, or do you have to have a hollow jar, thin jar, or a skinny jar, right? It's so let's first of all try to understand what those are, and then we'll see how Wildfly Swarm can help you with that, right? So the first part is the fat jar, which is the big box, right? Which contains your app runtime and your app and app dependencies, right? The two boxes, which is runtime and your app dependencies, right? Now come back to the, so let's go to the thin jar approach. The thin jar approach is what? It just contains your app and your app dependencies, right? And the skinny one is just contains app. It doesn't contain your dependencies, right? Why do we care? I'll just give me a minute, we'll go there. And then hollow jar is just which is just your server runtime, right? You could just create the server runtime and reuse it. Let's say you want to standardize the runtime in terms of specs, right? Whatever the subsystem, and then you want to use, whoever developing the apps, they will just use your hollow jar, which is your server runtime, and then deploy their WAR file, which is in this case will be a thin WAR file, right? So why do we care? If you look at the Linux containers, right? Obviously, the way it creates is by layers, right? A thin WAR, it contains, obviously, you have binaries for, a kernel is shared, as well as your JDK or app server, right? And then you have libraries, which are, in this case, your application dependencies, and then your application. So you're creating that many layers for your Docker image, right? Versus on the right, which is a Uber jar, you are creating just OS, Java, and then your Uber jar. Well, why do you care? The thing is, in a containers world, right, the layers could be reused across, right? So if you're deploying, let's say if you're just, all you're doing is just changing one layer of your application, just one line code or one module, right? You shouldn't be technically deploying all these layers, because one, obviously your DevOps team is trying to build all the modules. Second thing, storage, right? Obviously, it's not caching it. It's obviously every time it has to get the new module or a new layer created. Versus on the right, you don't have an option. You're just rebuilding and recreating and doing that layer every time, right? That's one of the discussions. Obviously, I have seen in many places, and also customers asking about which one. And one of the use cases I was actually one of the customers I was working with, they were like, what, we do not even know what's our end deployment looks like. When I say end deployment, we might be deploying, so they usually deploy in a customer infrastructure, right? Sometimes the customer says, I want in a container world, or they'll say, I don't want container, just deploy in a normal non-container way, right? So in this approach now, what they were trying to do, yes, sir?
No, but I mean, if the application on top is just a thin jar, it's not a deployable unit, right?
Which one, the libraries?
No,
or
the application without the libraries and that server, it's not a deployable unit, so why do you care about it really?
Well, let's say you are,
In terms of deployable units.
yes, sir. So let's say if I'm depending on one module in an application, right? Let's say my REST app depends on a common entity library somewhere. Let's imagine that, right? Now, if you're deploying a fat jar, you're deploying just the jar, plus you're deploying both jar as well as common entity. But technically, you're just changing your RESTful services, but you still have to deploy both together, right? Which are layers. And the way you could do it, you can solve it in a container world is, at least in a Swarmify way, is you can create that common modules or whichever you think are reused across most as a common fraction, and then deploy it as a fraction, so that whenever the app is deployed, it's actually reusing the same fraction versus rebuilding every time, compiling, building, versus you're saving network calls too, you're saving storage, etc. and others. Hopefully that answers your question.
I guess to a degree, but the thing is, my point is that if you have an application jar and the library is separate, you just change one library version. The whole thing may not work.
Well, that's correct. Correct. So that's the pipeline you have to come up with, right? That's something you can solve with a. I mean, again, if you're not worried about memory or your meaning in terms of the layers not reusing, or if you're not really care about in terms of the network calls, as in it's in the build time, right? We're not losing anything in the runtime, right? If your DevOps team or if your team, you're not really worried, you could still continue to do it. But some people are like, hey, you know what? Why should I build this system when I'm not even not even changing that particular module at all? If it not work, so the way people solve it is, create a pipeline that could, whenever the common modules have changed, they'll have their own pipeline. And then because as I said, two pizza rule, they have their own team which is running their own pipeline. And then the other team, whoever is sharing this, whoever is creating these RESTful APIs, they have their own pipeline, right? And then you have an integration pipeline on top, which is actually doing your automated testing for both your modules together, whenever things change, right? It all, again, you can automate all the pieces together in a way that kind of works for you. All right, and we talked about HoloJar as well, right? So let's start with a small demo in terms of see to have a. Let me just show my one. Do I have a? All right, yeah, actually I'm on a packaging demo, right? So in the packaging demo, it's again, there is nothing in terms of changing in the API, meaning in the pom.xml is the same pom.xml, right? It still has the same as in the main REST endpoint and the RESTful, etc., right? So now you're trying to build it, but in terms of the building it, right? So you could, rather than saying build everything, you could just pass a runtime variable which says, just create me a HoloJar. So that, again, this is useful in the cases where it depends on how much your operations and dev team wants to take control, right? In some cases, if your ops guy says, you know what, I just want to take even though we're building FireJar, I still want to take the control on building those actual bits inside that server runtime, then by doing the Holo approach, you're just doing a server runtime, you're reusing a server runtime as well as you're just deploying the var, which is what you're changing here, right? So in this case, I'm just saying, passing a flag which just says, do this, right? Let's go to hopefully I'm keep forgetting. I have a spelling mistake there, but that's fine. CD target. Is it done? All right. So here, right, in the target, now it created two separate ones. One is a Holo Swarm jar, another one is the packaging var, right? And the way you do it, the command, otherwise I have to type it. And the way you run it is just say Java jar, right? Then packaging, packing demo, HoloJar, and then give your var file. So I'm giving my server bits, and I'm just telling take my var bits as well. Something failed. All right, I have my server running here, I believe. Yeah, the server already ran here, right? So let me just kill it. Let's rerun it again. All right, now it's ready, right? So it still works, right? So you're using just the server bits as well as the var file, right? Very simple. All right, and I also want to show you a couple things in terms of the fractions, right? So here, where's the one fractions?
That's not faster than the previous demo. The
Right, because this is just reusing the same subsystem, right? So versus it's already knows what subsystems it needs in the runtime. In the previous one, what I did is it actually auto detecting the fractions. So it takes a little bit of time to detect the fractions when it's running, versus you already have a fraction that is detected and running the var file on top of it.
700 off front end, 1670.
Yep. So I wanted to show you one thing is the installed fractions, right? So if you look at the fractions that it installed, it's no more detecting the fractions, like I said. It's just doing installed fractions here. Versus if you run the previous demos, it will tell you one way is you can turn off the auto detection as well, as in tell the plugin not to detect your fractions if you already know what fractions you are. But this is quite useful when you are doing migrations from your EE world, right, Java EE world, where you do not know what the code is using. So you just put the plugin, enable the auto detection, and it comes up with a list of fractions that it detected, and then based on that you can do iterative, kind of changes. All right, so let's go back to our slides again. All right, so we did that. So now look at the configurations, right? So obviously this is one of the things we wanted to. Every app has a configuration, right? And the way the Wildfly Swarm boots is it boots at the default main, right? But if you want to override the main, you could provide a main like you did here in the diagram here, and you could right now so the recommendation is not to use main. Go with the YAML file approach rather than creating your own main, right? The reason why you would override main is because you might be wanting to kind of configure the fractions itself, right? This is all convention over configuration piece, right? Where 90% of the use cases are already covered with the fractions out of the box. But if you want to just say, I want to further fine tune the fractions in terms of passing the parameters and properties, then one way is to put your own main. And here I'm just instantiating my JAX-RS fraction on the left, and then from there you just do whatever configuration you want to. And the way you configure the plugin is on the right side, where you just say main class is this, right? And then it's similar, like again, as I said, you can do the same sort of things on the main. On the right, you have the YAML approach, pretty much same in the whatever stuff you see on the left, you could do everything on the right, YAML approach, right? And you can override the configurations, in a bunch of ways. Through the Maven plugin is one way. You can pass properties, -d properties, or you can, if you have it, let's say if you are using Wildfly application server, you can pass the standalone XML to itself by saying by C -c, and then you can also do environment specific configurations, right? You can come up with different YAML files which are specific to your environment, and then while you're starting your Uber jar, you're just passing that particular YAML file relevant to your environment, right? And the way you invoke that, the environment specific configuration looks something like this on the left, which is project stage development, project stage production, and then when you're invoking it, you're just invoking with the -d flag, which says development or production, wherever you want to deploy your Uber jar to. Any questions before we're doing on the time? We good? 55. Okay. 30 minutes. Okay. So we talked a little bit on the auto detection. So the way auto detection, the way you enable or disable auto detection is, there is a configuration on the plugin which says either do it or don't do it, or just do it whenever kind of want it, right? Always only when missing, only if it sees some missing fractions when you're deploying it, or never do it. Oh, let's look at the JDBC driver, right? Obviously, this is one of the things you probably will be when you're working with the application. Every app has a driver, right? So data source auto detect, right? So this is one of the project. Already, I have the code for it. Again, the code is nothing. It's just to simply show you a lookup, data source lookup for this particular data source works, right? That's all you need. Once you get the lookup, it's the same thing, right? So once it gets the data source is getting the connection, right? And here, if you look at the POM file, all I have this on this one is just putting a dependency on H2 database. I'm just using H2 in-memory database, right? And then I also, these are the two things that is required for Swarm to auto detect that particular driver and create it as a module within. If you know how Wildfly application server works, whenever you have a dependency, whenever, let's say in this case driver, right? If you have to use a driver, one way is you can put it in a WAR file library, versus the usual recommended path is just put it as a module within the EAP subsystem, right? So what it is doing right now, if I'm just putting a dependency on H2 database, it's just taking that dependency and creating that module as a subsystem within that Wildfly Swarm, which you do not even know behind the scenes, but that's what it's doing. It's creating that as a module and then putting it in the class loader path so that it finds where the driver class is, right? So let's simply run this. Again, the code is just, I'm just looking up the data source and then and just creating the dependency I have is just on the H2 data source. I might have already created, yeah. Again, nothing different, it's just a Wildfly Swarm run, right?
How does it know where in JNDI to find the data source?
So there is a file, you can bind it one through the normal way persistence.xml, or you can bind it to the YAML file approach too, where you can say, actually, I think I have that too, where I created a, I might not have it, but let me show you this one. So there is a YAML file, and obviously when you deploy, when you develop microservices, you're just going to deploy as well, right? So this is where you deploy, define your data sources or configure it.
So why do I have to declare the data sources fraction in addition to the H2 database?
You just define the module dependency as in your H2 database. In an application, in a typical EE application, you still define a H2 driver as your dependency, right? Correct?
I guess, yeah.
So you're still doing the same thing, but if you're deploying into a Wildfly application, it needs to have a subsystem, or in a runtime, it needs to find where the driver is, right? So here we are swarmifying, meaning we are doing a fat jar approach. So it's taking that driver, right, the module bits, and then creating that as a subsystem within that fat jar so that it can find the driver in the runtime when it's looking up. All you're doing is just creating a dependency on the H2 database. That's all your driver.
The idea that I have the driver already as a dependency there, why do I have to add?
You might not want to use it as a data source. You might just want to use it directly as a driver. So by having a data source, it will auto detect that you're trying to set a data source up.
Right. Thank you. So what it does, based on the dependency, it actually creates an example data source. Based on that particular dependency, it creates an example data source. Here,
Data source fraction ensures that the data source is created.
right, I'll just show you the data source created. I'm just looking for that particular. So it's doing auto detect, example data source auto detect, it install the fractions, auto detected JDBC driver for H2, right? And then it's creating, actually it will create an example data source as well, bound data source example DS here, right? And that's all it needs, right? So in my code, I'm just looking up the example DS here. Is it? Issues apart. Right. So it just giving you a connection which says, hey, I'm using the data source from it. So all you didn't even change anything. It just detected the driver by itself, and then you're using the data source in a similar way what you're doing before. It's one way, it helps you in migrating your applications for sure. Again, the project defaults.yaml, configure data sources and things like that. In the YAML file I showed before, I actually have employee DS as well. I wasn't not using it, but I just wanted to show you. And if you want to pass that extra YAML file, you're just passing Java jar, just passing that particular YAML file with a -s flag there. All right, so now getting into the actual, a little bit on the cloud native Kubernetes OpenShift stuff now. Swagger, we already saw it. Basically, you're just defining the fractions. Someone asked about web app UI as well. UI app. So there are the two fractions already there. That's how you define it. And then on the right side, you just say API description annotations, whichever however way you want to describe your API, right? It's pretty simple. We already kind of saw the demo there, so I'm not going to show you again a demo. For service registration, right? Again, this is for the lookups. It's not probably helpful in a Kubernetes OpenShift world, but if you're doing, if you need still some sort of lookup, you can still use it. And the way you could configure the fraction is on the left. You're just configuring the fraction console, and then you're using the product defaults YAML. Just configure where your console server is running, and then you're annotating your class with advertise here. It just in this case, I'm just saying personal service. So here you have two services, which is pricing and is registering, and when someone looks up by the string, person service, they should be able to find it from here. Again, in a Kubernetes world, obviously the way it works is it basically works by the strings. Let's say if I'm calling a MySQL, or let's say I'm calling a service persons in this case. I'm just saying my persons. I'm just saying person / whatever URL is, and OpenShift injects that environment variable for you without you having to worry about the lookups. But in some cases, if you still need it, you should be able to use this one as well. The circuit breaker pattern is hopefully everybody aware of what circuit breaker is. But essentially on the right, if you want, if let's say if there is a request that comes in, and if there is a fault or if there is an error in one of your service, right? Then you want to have a fallback mechanisms, right? Rather than failing the entire stack or service, saying or not responding at all. So in this case, if there is no fault, it just directly go to the service. If there is a fault, it goes to fallback method. And the way you define it here is basically you're just defining the annotations. You create a fractions on the left, dependency as a historic fraction, and then you're calling and you're just calling your service. And whenever there is a fallback here, which is what you configured, my fallback method gets invoked, and your fallback will invoke whenever there is an error. I'll show you this demo in a little bit. Health checks then is a part of the spec, the micro profile, and the way you include is the fraction as in monitor, right? And then all you do is it's an HTTP endpoint. You're just annotating with the health, right, and returning the status of it. If you say up or you can have one method for both readiness as well as liveness probe checks, or you can have multiple methods that aggregate something which just tells you, hey, I'm up and running. You can do that as well. And in a typical outside of Kubernetes orchestration world, you could call this endpoint to see, hey, what is my app up and running? Is it working? Things like what's the state of it, right? So you'd be querying it probably using a scheduler or some sort of ping kind of it, right, on the right. So let's again, this is not someone has a question.
Can you go back to the previous slide, the circuit breaker?
Yes, sir.
Yeah, I found out the dependency and there is using histories.
Correct, sir.
And I remember histories is from Netflix.
Yes, sir.
Yeah, I saw the group ID is a Wildfly, so does JBoss come up with their own version of histories or what?
No, it's actually the same history that we are working on Netflix OSS. It's the same Netflix OSS stuff that whatever you saw or whatever you've been used to.
Just, I think you're wrapping it.
It's just a Maven. It's just we are putting the coordinate on the swarm and then pulling it by the by a fraction.
There's a wrapper there.
Right.
That will internally depend on. I think they had same thing for console also.
Yeah.
Seen in the previous slide, they had
Every fraction is worked in a way that works with. It's not a code that we add. It's something that you to make it work in a fat jar approach, right?
Okay, so the group ID is all the Wildfly wrapper.
Yeah, I mean, this is the way. So the thing is, you are testing. So the community might be going, adding, and doing some sort of additions on the histories, right? You do not want to pull that every time you build it, right? You want to get a stable version, put it in your flat, and then you run it. And then when you get a new version, you put it in the same and then run it. You do not want to just do the non-stable versions or snapshots.
So this kind of using your own like internal kind of stable version.
Correct.
Okay.
So which version it is mapped to is present in the form codex?
All these versions are mapped to the Wildfly Swarm version, which is 7.0. If you look at the Red Hat runtimes, OpenShift Red Hat application runtimes is 7.0. But if you look at in the community side, it's actually a different number, which they go by some year 2000. In this case, I'm using 2018 3.1 release. This is on the community, but on the Red Hat, as in the product side, you would be using just a 7.0 everywhere.
So is there anything about dependency injection?
Yes, there is a fraction for the CDI as well. Everything is a fraction. Whatever you could do in a EE world, you will be able to do everything with the swarm. All right, we talked about health checks, and there is much more to it. Obviously, with the time we have, we could only cover a few, but if you're interested, we can obviously come back and do another one for sure. Let me show you now the OpenShift stuff, in terms of how you can deploy this in a typical OpenShift or a Kubernetes. Anybody heard about OpenShift here? Okay, cool. Anybody working on OpenShift?
Is OpenShift Red Hat's version of Kubernetes? My understanding.
Yes, it's an enterprise Kubernetes. I wouldn't say Red Hat version of the Kubernetes. I would say it's an enterprise Kubernetes. So the way Red Hat so all the products that we do, it's based on community. So our development arm is a community version, and when we are productizing we are doing QA on the development branch, and then making sure we're fixing all the bugs and doing all the QA, etc. And at the end of the day, the bugs and all that will still go to the community version as well.
Okay, the bug fixes goes back to the
Yes, there is a two-way pipeline, but it's not like one way, like other people do, like a closed open source. That's not the way. We do it both ways. So this is the OpenShift console. I have a bunch of projects here. So there is a launcher that you can use on the OpenShift as well. The launcher will help you to create or getting you up to creating your kind of first apps, right, very quickly. You could deploy it on your own OpenShift instance, as well as you can deploy it as you can use this and deploy it on OpenShift Online, which is our public cloud version of OpenShift. Right. In this case, I'm creating an app. I'm just so there are two options here. Do you want to create on OpenShift, or do you want to just create, build, and deploy locally? I'm just creating on the OpenShift. I'm just saying use OpenShift Online, which is my instance because I configured the launcher to be my own instance. So here it comes up with a bunch of missions. In this world, it's called missions. Missions are basically a way to kind of a use case, right? A use case is like in this case, you have insert, deletes, updates and things like that. Or if you want to just do a circuit breaker, want to see how it works and kind of do it and then deploy in OpenShift, you could start that with that as well. So let's do the circuit breaker, right? So I'm just selecting the circuit breaker here. That's the use case, right? And then it comes up with a bunch of options in terms of the runtimes that Red Hat provides, things like Vertex, Node.js, Spring Boot, Wildfly Swarm is one part of runtimes. Then I'm in this case, because it's a Swarm talk, I'm selecting Swarm. And then you have to give a project name here. Here I'm going to give, this is health check, right? Health check AJUG demo. This is just a project name I'm giving, right? Sorry?
You did circuit breaker.
Oh, I'm sorry. Sorry. Thank you. See, my mind is not working. Thank you. Circuit breaker, AJUG demo, right? And you can configure in terms of the artifacts however you want to. I'm just doing this way now. So now it's asking you, we are ready. Do you want to launch it? Hopefully it'll work. If it doesn't, just don't trust me. But what it's doing here is it's creating an app for you. So it's creating that circuit breaker app. It's checking in the code in your GitHub repository, whichever GitHub credentials you give. And then once that code is there, it's also at the same time building that bits, creating that from the bits, creating an image, a Docker image, right, and then deploying it on the OpenShift, right? And that's what the steps are here, right? So it's done. I see all the green buttons. Now there should be a build already started on the OpenShift. You can go here. So that's the AJUG circuit breaker demo I was doing, right? So here you see my build is running. Expand it. My build one is running here. So now it's compiling, it's downloading the Maven dependencies. Obviously it's Swarm, so it's building all the fractions. It takes a while. Yes, sir?
Just created an R ago. I thought you just created it.
Let me see.
Just about that Maven logs you see, right?
Yeah, I don't know. This it might be.
No, yeah, it says created an R ago.
Yeah, I saw that. It might be not updated. Maybe let me try again. Let's go back and see. Circuit breaker.
I don't think that was the name, right? We named it AJUG circuit breaker.
Oh, I did? Okay.
First circuit breaker, AJUG.
Yeah, the first one, circuit breaker AJUG. Yeah.
The example says no.
Right. Just let's go back here. No confusions. All right. So let's first of all go to our GitHub, right? So I configured my GitHub, right? Here I'm just looking at the repos. So it updated 2 minutes ago. This is what the launcher created, right? Circuit breaker AJUG demo. This is the one.
Yeah.
It might be just a timing. I don't know.
Zone is not Eastern.
No, I don't know. So this is the one in the afternoon I was doing, and it exactly shows the 5 hours ago. Maybe I was having the same project name before, or we can just create a new one if that kind of makes you guys, yeah, that 1 hour.
Curious on was it done now?
Right. It says 23:10, right, which is what time zone 23. Yeah. It's the same time. That's what. This is just not updated for whatever reason. I don't know. It might be, which I haven't noticed.
Compiling all this time anyways.
Yeah. I'm not. I don't even have internet connection while I was driving 1 hour back.
Where are you located?
I'm incoming. All right. The build is success here. So it still had to deploy it, right? So while it is doing it, let's go back and check out the project and then see what it does, right? So do I have the code already? I'll check. No, right? All right. So where am I? And the targets. Let's go back to. Let's put them in a Wildfly Swarm projects. Git clone. So I'm cloning that project here. Right, it's done. Let's look at the code. Let's close these projects. Yeah, we'll stop it. Existing Maven projects, browse. Work, is it not in the workspace? It's not in the workspace, right? So it should be in my AJUG mod 12, and then this is the circuit breaker demo, right? So just recognized it. Now I have to come up with the better names next time when I'm doing this demo. So this is the project I just imported, right? So let's look at the POM file here. So we still have the plugin, the WAR plugin, as well as we have Arquillian, because it's also using the integration testing or in container testing for testing that endpoint. And then the bill of materials for it, and then where is the actual? So this one is just auto detecting, I believe. So let's open the. So if you don't include any fractions, it auto detects by itself. So here, in this case, it did not include any of the actual, for example, RESTful stuff, right? So it did not include any of it. So it's going to auto detect it because there are no dependencies on the Wildfly swarm. It automatically detects it. So there are two. So let's open one of the file here, right? So greeting endpoint is the first one. All it is doing is just doing a greeting. Obviously everything in Histrix is a command, right? So you'd be using commands here. It's basically what it does is, it's sending a close signal. I'll show you the UI, but it's sending a close signal to mimic the failure so that the path would be open for the failure, right? So essentially just calling the greeting service, actually just doing the command and executing it. And there is where is the other one? Let's look at the, excuse me, look at the Histrix endpoint. You can pass all the thread pools, etc., time retries, etc., through the YAML file or through the command line. And the name command is another one. See, creating the command, and then the fallback is whenever there is a fallback, it's actually sending this string. Let's look at the UI a little bit. Hopefully that's ready. Okay, that's ready. Circuit breaker AJUG, right? So that's the UI. That's the app that's got deployed. Now this circuit, this guy is calling. So whenever the greeting service is calling the name service. So whenever I'm just invoking it, it's going to print here as well as it shows you here, right? So I'm just invoking it continuously. It just shows here. Now let's say I go back to OpenShift world, right? And then, or actually let's do it from here itself, right? Toggle. I'm just toggling the state for that service to just return the fail string, right? I'm just mimicking it. So now you should be seeing fallback, the method. You see it, right? And then if I toggle back, obviously you'll see the hello world again. Right? Any questions? Sure. This time we have 10 minutes, 4 minutes. Okay. I just want to walk through the health checks as well, and that should kind of what I wanted to cover. So I must have already deployed the health checks. I want to show you so health checks, I deployed it in the afternoon just to show you. So health checks is basically, if I say, so it just says appends it hello, right? Now let's go back to the health checks app, right? So it has a star app, and then if I bring down one of the service here, which essentially means scaling down the app, right? So what OpenShift should be doing is, so whenever I stop it, or kill it based on the URL, right? It should be restarting the, actually, let me see.
I think it took a little bit to stop.
Yep. So it's restarting the pod here because it figured. So the health check API, what it says is whenever essentially there's an error in the pod or an application / service, it should be trying how many times based on the configuration, and then it should be restarting the pod based on that, right? So again, the health check itself, the endpoint itself can be configured like the way I showed you before. Let's see, come back, and now again the app itself works. Just to show quickly what's the code is behind health check. Right, so it's a greeting is an entity or an object. Health checks is essentially I'm just exposing health, putting annotation on top of it as health. In this case, I'm sending. So what it's doing is it's using Wildfly Swarm CLI commands to create just saying stop the service, right? So it's kind of mimicking the failure here. So when I said invoke, it stopped it. Stop the particular service. As soon as the OpenShift sees that the service is not running or it has issues, then it's going to restart the pod.
So that's a health check on another service, not on itself.
Sorry?
The health check on a different service, right? Not on itself.
The health check. So this health check is essentially you're creating a health check. You're exposing a /health URL here, right? So what I was doing on the UI is whenever I'm just checking the health or when I'm stopping it, it's using the CLI commands to stop it. Let me open the other one too, right? /stop. So when I use the stop command here, it's invoking the stop here. It's putting the server in a suspended state. The service that is running or the Wildfly Swarm instance, and then as soon as look at the comments here, right? As soon as the server stops, Kubernetes is restarting the particular pod. Any other questions? I think we are right there on the time. 5 minutes.
Any support for unit testing?
It is good that you asked. There is, I mean, you could create the JUnits, but usually in a microservices world, you want to do a contract-based testing, right, as well as in container testing, right? So Arquillian, which is again the JBoss project, I'll show you here. Hopefully there is an example somewhere. It should be with IT. Yeah, but as there is the Arquillian is a framework where what you could do is if you annotate a class, a test case with an Arquillian, run with Arquillian, what it is going to do is it's going to create that particular artifact, either var or jar, right? And then it's creating the container behind the scenes, deploying it inside the container. It's running the test for you, so that you can run the test within the same container. It could be your integration test, or you could do a contract-based testing if you're just doing that container. Let's say if you want to act as a client as in service client, right? Then if you take out that annotation, if you just say, if you don't put the annotation, that defaultly you can just run it as an out of the container testing, where you can do kind of, invoking the API, testing the response, etc., those kind of stuff.
But when you run your test, it will start up a Wildfly runtime environment.
Correct. It's going to start up, and it's going to run inside the Wildfly.
And you can either run inside the container or
Outside the container. Correct. It's pretty powerful. That's one. Yes, sir.
What would you say is the biggest advantages compared to Spring Boot, for example?
I mean, Spring Boot, I love Spring Boot too. It's this is basically what the problem we are trying to solve is on the EE side of it, right? Obviously, Spring Boot is specifically geared across your Spring applications here, but we see a lot of people running still EE apps. It's not that EE is going to go away tomorrow. It takes a while to even get off the EE, right? And on top of it, if you still want to run like Spring integration bits and those things, you can still run those bits, integration bits, like Spring integration, Spring data inside the Wildfly swarm itself. But it's just your choice, right? Versus using Spring Boot or not. We use the difference. One of the difference I see is Undertow itself is a very powerful, right? Which comes out of the box with the Wildfly swarm. Even Spring Boot guy says use Undertow. So that's one of the. It uses an I/O behind the scenes, I/O threads, buffers, all sort of nice things behind the scenes, and it's very fast. That's our runtime is one part of it. And if you use Spring Boot, obviously you have a different approaches to doing Jetty versus Tomcat versus whatever bits, right? But what I feel that running the container bits also are important because that's where your application is running. When I say container, the server it's running, the servlet container or whatever container you're using behind the scenes. Any more questions, sir? Right. Thank you so much for. Hope it's helpful. Thank you.